Hi, and welcome to the video for Chapter 19 on confidence intervals for proportions. So let's get started. So let's rate your confidence from 0 to 100 on what you believe, um, how old I am. So even like make your guess within 10 years. How confident is your guess within plus or minus 10 years of my age? And some of you may know my age, but again, how confident are you for guessing my age? Or what about within 5 years? So again, guess my age and you're within 5 years. How confident are you in the, or how confident are you within 1 year of my age? So again, that's what the confidence part that we're talking about in chapter 19. So what about this one? If you shoot a basketball, now a wading pool is those little kiddie pools that you have a little water, or just, I mean, let's pretend it's not has water in it. You're just taking a little basketball, and you're throwing it into something with a large diameter, such as a wading pool. How confident are you to make that basket? What about shooting a ball at a large trash can? So, like one of those 55-gallon trash cans. How confident are you with that you'd make that basket? What about shooting the ball at a carnival or one of those small little circles, a dot on a thing, and you're throwing something like a ball at one of those? Hopefully, you get the idea here that the larger that something is, the larger your confidence is. So what happens to your confidence as the interval gets smaller? Hopefully you get the idea. The smaller your confidence, the smaller the interval. And likewise, the larger your confidence, the wider the interval. So here's our confidence intervals. Confidence intervals are used to estimate the unknown population proportion. So again, we're taking the information we learned in chapter 18, and again, we're using those estimations of the unknown population proportions. And there's simple formulas that we have to deal with, where you take your estimate and you add or subtract your margin of error. And we take a look at this interval that is created, right? If you have the middle as your estimate, and the subtraction of your margin of error is your lower bound, and the adding of your margin of error is your upper bound, and you have this interval that's created between those two things. And to be able to use a confidence interval, you have some conditions, just like before, that you had to worry about. And they are these four things. You need to have plausible independence. So meaning you should have mutually independent conditions, just like you had in chapter 18. But this one again is checking, is there any reason to believe that the data values somehow affect each other? They shouldn't for using confidence intervals. The randomization condition, again, was the data sampled at random. The 10% condition, was the sample less than 10% of the population? And a success failure condition, do both NP and NQ, are they both greater than or equal to 10? And again, if these conditions are satisfied, then I may use a normal model to find what is called a one proportion Z interval. A one proportion Z interval. Then we move on to margin of error. our margin of error shows how accurate we believe our estimate is. So how accurate we believe our estimate is. And the smaller the margin of error, the more precise our estimate of the true parameter. So our true mean, for example, or our true p. The smaller the margin of error, the more precise our estimate of the true parameter is. So again, this deals with your margin of error. And again, there's another formula that we will take a look at. And it is basically your margin of error, or M. Be careful that this M is not slope, it's the margin of error, is equal to your critical value, which we'll talk about in a little while, your critical value times the standard deviation of your statistic. So later on when we get to our problem, we're talking about margin of error in here. Again, we'll come back to this and we'll be filling in what the critical value is and the standard deviation of your statistic. And remember, your standard deviation as your statistic may change depending on what type of data you have. So depending on what data you have, whether it's categorical or quantitative, you may have different formulas for your standard deviations. So let's take a look at what's called a confidence interval or confidence level. Now your confidence level is the success rate of the method used to construct the interval. Again, it's the method used. So here's sort of like one of our recipes from earlier in the year when we were talking about recipes for like R and R squared. Here's our recipe for your confidence level. And it's basically this. It's using this method, blank percent of the time the intervals constructed will contain the true population parameter. Using this method, blank percent of the time the intervals constructed will contain the true population parameter. So out of these three things here, these three sentences, what does it mean to be 95% confident? Does it mean 95% chance that P is contained in the confidence interval? Again, what did we just say that the recipe was? Is it this? No. Again, it's not this that we're looking at. Is it the probability that the interval contains P is 95%? No. No. It is the method used to construct the interval that will produce intervals that contain P as 95% of the time. So I'm going to pause here for our video and then go on to our next one. So be right back.